A Bose-Einstein condensate, or BEC for short, is a new state of matter unobtainable in nature. It was first predicted by Indian physicist Satyendra Bose in 1925 and further developed by Einstein. So let's break this down and put it into context. In everyday life, the common states of matter are determined by the movement of the component particles. For example, in gases, the particles move around rapidly and are far apart and have a lot of energy. When you cool gases down, the particles move slower and become closer together to form liquids. Cool the temperature even further, and the particles are so close together that they can no longer freely move, but only vibrate in a structure. This is known as a solid. The important thing to note is that the motion of the particle itself is actually heat. That is, the less active particles are, the lower the temperature. Okay, so now that we've got that, let's keep cooling until we reach the next state of matter beyond the solid, the Bose-Einstein condensate. So as it turns out, if you cool things enough to about 1,000,000 times colder than anywhere in the universe, something interesting happens. The particles become so still that they lose their individual identity and begin to behave as one. If that's not strange enough, the particles stop behaving as particles and begin to behave like waves instead. This new strange state of matter is the BEC, or Bose-Einstein condensate. BECs are some of the coldest objects in the universe, far colder than outer space, and typically less than 1/1000,000th of a degree above absolute zero. They do not exist in nature. Okay, so that's all well and good, but what are BECs useful for? Well, because BECs are so cold, they don't vibrate very much, and this makes them extremely sensitive to external disturbances, which allows them to make very precise measurements, such as tiny changes in the Earth's magnetic field or gravity itself. BECs have also proven very useful in exploring a wide range of questions in fundamental physics. They can also do some pretty cool things, like slow down light to a few kilometers an hour without losing any information, or allow us to understand other aspects of the universe, such as neutron stars. So now you know that Bose-Einstein condensates are very useful things in physics. The only problem with them is that they're very difficult to make. So how do you make a BEC? In basic terms, extremely precise lasers are used to nudge and bump atoms and reduce their movement so much that they enter a very still state of matter. The first time this was done was 2001, and it won 3 physicists the Nobel Prize. Okay, so now this is where things get very interesting. In May of 2016, a research team at the Australian National University created an artificial intelligence machine that was able to learn this Nobel Prize winning experiment by itself from scratch in under 1 hour. The AI was given control of the lasers and was free to do whatever it liked. According to the researchers, this same procedure would take a simple computer program longer than the age of the universe to run through all the possible combinations. Generally speaking, it seems that AI keeps surprising us by one of 2 main ways. 1. Finding the correct solutions to problems by using methods that seem very strange to humans. Or, number 2, by just simply being better than we expect. As it turns out, both were the case here. Here's a quote from co-lead researcher Paul Wigley. Quote, "I didn't expect the machine could learn to do the experiment itself from scratch in under an hour. It did things a person wouldn't guess, such as changing one laser's power up and down and compensating with the other. It may be able to come up with complicated ways that humans haven't even thought of to get experiments colder and make measurements more precise. Next, we plan to employ the artificial intelligence to build even larger Bose-Einstein condensates faster than we've ever seen before." End quote. Dr. Michael Hush, another lead researcher on the project, says that the AI system's ability to set itself up quickly every morning and compensate for any overnight fluctuations would make this fragile technology much more useful for field measurements. Quote, "You could make a working device to measure gravity that you could take in the back of your car, and the artificial intelligence would recalibrate and fix itself no matter what. It's cheaper than taking a physicist everywhere with you." End quote. According to the research paper, other uses for such AI technology include quantum chemistry, femtosecond physics, and quantum computing. The idea of artificial intelligence theoretically being used in the field of science isn't anything new. Demis Hassabis from Google's DeepMind did mention science as an easy pick application for AI.
Well, the thing I get most excited about, if we look sort of 10 years plus out, is using developing the type of technology that we publish now a lot further, and building up those capabilities so eventually we can have, say, scientific advances being assisted by AI, either AI scientists or AI assisted science, and actually making new breakthroughs with the help of machine learning, like the sort of machine learning we do.
So in conclusion, it seems like AI is just starting to turn that corner from simply being an interesting idea to actually being practical. More specifically, an AI that can easily create a BEC could have profound impacts on science and technology. If you remember in my biocomputing video, I stated that researchers were looking into alternatives to quantum computers because they were largely impractical due to the near absolute zero temperatures that they needed to even function. Previously, it would take a team of physicists a long time to painstakingly adjust parameters to get down to a temperature where a quantum computer could function. But now, artificial intelligence could do such tasks in under an hour. Breaking down this barrier now brings us one step closer to practical quantum computers, and other things such as atomic lasers.
We cool down substances near absolute zero.
We're still not to absolute zero.
Yeah, we can't reach it. That's the third law of thermodynamics.
Right.
But the Nobel Prize was given to scientists like at MIT that actually created Bose-Einstein condensate in the laboratory. What does that mean? Atomic lasers in the future. Okay? Some people even think that it may give us a shortcut to teleportation, a new way of just literally beam atoms across the room, if you can master the art of quantum coherence.
So I guess artificial intelligence is just scratching the surface of science, and the number of scientific breakthroughs aided by artificial intelligence in the future could be staggering. We'll just have to wait and see on this one. Alright, that's the end of the video, so thanks for watching guys. Give this video a thumbs up if you liked it, subscribe if you're new to the channel, and leave a comment below sharing your thoughts. I also want to thank those of you who have been very supportive over Twitter. Those of you following on Twitter would know that my family's going through a bit of a tough time at the moment, and out of respect I can't say exactly what's happened, but I do appreciate all of your kind words and support. It really means a lot to me. Alright, cheers guys, this has been Dagogo, you've been watching Cold Fusion, and I'll catch you again soon for the next video. Have a good one.